Hey everybody, this is a quick video to show how to do problem 5 on assignment 8 for Econ 1B's homework. So this is the homework looking at, you can kind of see it, looking at firm costs, marginal productivity of labor, those kinds of things. So question number 5 is about Nimbus brooms, and you get the workers and the output, and then you need to start filling in this table. So the first thing the table asks you to do is find the marginal product of each worker. I should have written that better. So the marginal product of each worker. Well, the good news is when there are 0 workers, there's 0 marginal product. So we don't have to worry about that first one. And then we want to go through and see how much each additional worker produces, right? Instead of looking at the marginal cost, now we're looking at the marginal productivity. So the first worker takes us from 0 to 20. So the marginal product of that first worker is the 20 units that worker produces. And if you aren't familiar with this, you might want to go back and look at the slides where we started to talk about Farmer Jack hiring workers, and we looked at the marginal product of each worker, right? The first worker gave us 1,000 bales of hay, the second worker gave us 800 bales of hay, and so on. Now we're just looking at the marginal product, the additional output each worker creates. The second worker right here takes us from 20 to 50, so that's going to be a marginal product of 50 minus 20, or 30. Then going from 2 to 3 takes us from 50 to 90, which means now 90 minus 50 is 40, and so on, right? That's what that marginal product is. If we go from the third worker to the fourth worker, we go from 90 brooms to 120 brooms. That means that fourth worker makes Nimbus 30 more brooms, and so on. Going from 4 to 5 takes us from 120 to 140, and then from 140 to 150, and then from 150 to 155. And we can already see the relationship we expect, the diminishing marginal product of labor, right? As we add more workers, they get more efficient and then less efficient, right? And that's that idea that we see with the average variable cost curve and the average total cost curve, and even the marginal cost curve, is that increasing efficiency and then that decreasing efficiency raising costs. So let's go to the next part. The next part says, if each worker costs $100 a day and the firm faced fixed costs of $20 a day, what are the variable, total, and average costs? So fixed costs are $200 a day, and wages are $100 per day per person. So variable costs are going to go up as we hire more workers. At 0, we hire 0 workers, so that's easy. At 1, we have 1 worker, $100 per worker. That gives us a variable cost of $100. 2 workers times $100 each is $200. 3 workers, $100 each is $300. 4 workers, $100 each is $400. And 5 workers is $500 in wages. 6 workers, $600, and 7 workers, $700. The fixed costs stay the same. No matter what, it's an extra $200 just for the firm to be in business. Oops. So if we go ahead and put our total cost in, total cost is going to be, remember, total cost is fixed cost plus variable cost. Fixed cost is $200 no matter how much we produce. Variable cost changes. So we start out with 0 workers, 0 output, and 0 variable cost. So our total cost is 0 plus 200, or $200. Our first worker produces 20 brooms, which is a marginal product of 20, and costs us $100. So $200 plus $100 gives us $300. Does that make sense? Does that kind of make it easy, make it sort of simple? Can you kind of see everything there? Hopefully. Okay. So then we keep going. 2 workers costs $200 plus fixed costs. And what we're going to see is we're just going to keep going up. 200 plus 300 is 500 by the extra $100 for the extra worker as we produce more and more brooms. 600, 700, 600 plus 200 is 800, 700 plus 200 is 900. Make sense? Hopefully. The next thing we have to calculate is average total cost. And average total cost is just total cost divided by output. And this is a little bit tricky because now output is changing by more than 1 per unit, right? So remember, average total cost is total cost divided by quantity. So in this case, we don't have an average total cost because we're not going to do 200 divided by 0. But average total cost at 1 unit is 300 divided by 20, right? So I'm going to get my handy dandy calculator out so I don't have to do math in my head. $300 of total cost divided by 20 output total gives me an average total cost of $15. My next total cost is $400. And I want to divide that by my next quantity, which is 50. So 400 divided by 50 is 8. Does that kind of make sense? Average total cost for 3 workers at our next level of output is a quantity of 90 and a total cost of $500. So $500 divided by 90 brooms gives us the average total cost of producing at that level. And that's how you want to think about that. If we choose to produce at this level of output with 3 workers and 90 brooms in production, how much does it cost to produce each of those brooms? The total cost is $500, so the cost per broom is 500 divided by 90. Or $5.56. Make sense? So we keep going down. Now we have $600 to produce 120 brooms. That next level of production, 600 divided by 120, is $5 per broom. So if we hire 4 workers, we'll get 120 brooms, and the cost per broom will be $5. Make sense? Kinda? If we only have 1 worker, the cost per broom is $8. But if we have 4 brooms, the cost per broom is $5. Average total cost is falling. And that makes sense because our workers are still getting productive. But I wonder what's going to happen for the next one. So the last one was $600 divided by 120. Now we're going to look at $700 divided by 140 brooms, right? 5 workers, $700, 140 brooms gives us a cost of $5 per broom. And that makes sense. Look, the marginal product of our workers is going down, and the workers still cost the same amount. So even though this 5th worker only made 20 more brooms, they cost as much as the 3rd worker who made 40 more brooms. Okay? So we keep going. The 6th worker gives us a marginal product of 10 brooms. So we have 150 brooms now. It costs us $800. 800 divided by 150 brooms gives us a cost of $5.33. And then finally, if we have a 7th worker, they're not very efficient, right? It only gives us 5 more brooms, even though it costs us another $100. So at $900 of total cost to produce 155 brooms, each broom now costs us $5.80.6. I'm going to say $5.81 and round up. Does that make sense? Hopefully. So what this is showing us is that the diminishing marginal product of labor drives this falling and then rising average total cost, right? The first few units are really expensive to make, and it gets cheaper and cheaper as each worker gets more and more efficient. As that efficiency drops off, as each worker gives us a little bit less bang for our buck, less marginal product, we're going to see costs stop falling and then start rising. Okay? And this gets back to that idea of efficient scale that we ended with on Friday, the idea that where average total costs are minimized is where you want to do business. If you think about this is the average cost per broom at different levels of production, if your average costs are falling, you'll keep hiring workers. But after hiring that fifth worker, hiring a sixth worker takes you from $5 a broom in costs to $5.30 a broom in costs. And I don't want to spend more to produce slightly more unless it's really worth my while. And that's that connection to firms' decisions. I hope that makes sense. Let me know what questions you have. Otherwise, have a beautiful day, and I'll see y'all next time.